welcome back to the channel. I had the incredible opportunity to sit down with David Smith, CEO and president of Robinson Helicopter Company. Earlier this month, Robinson announced the R88 at Verticon, and initially I thought it was great, it was beautiful, and then I had some time to reflect on it, and I was like, man, they really put the same rotor system on it that's on the 22, the 44, and the 66. It's like, you built this beautiful helicopter, new avionics, it's built for helicopter EMS, and it's like, you put the same rotor system on it, and I was like, man, did you miss the mark? And I posted a video about it. So I had the opportunity to sit down with David Smith, and I'll let you be the judge of this yourself. You can watch the interview and come to your own conclusions. But I have to say, after hearing the explanations and the thought process behind the rotor system design and all the other factors that went into it, I am way more bought into the project now. I can kind of see why they went with it, and it actually makes a lot of fundamental sense. So you can be the judge of that yourself. And the last thing I want to mention before the video actually plays, the interview plays, is after we filmed, David's team reached out to me, and we didn't talk that much about it in the interview, but they wanted to mention something about SFAR 73. If you're unfamiliar with SFAR 73, it stands for Special Federal Aviation Regulation number 73 that specifically pertains to the Robinson R22 and the Robinson R44. And I just want to read to you that part of the email that his team sent me. There is some huge info in here. I know the video will be uploaded unedited, but David requested, if possible, that you add to the discussion that SFAR 73 is only applicable for the R22 and the R44, and after being in place since 1995, last year the FAA passed a final rule in August that set an expiration of the SFAR in 2029, and I believe this is from David. Therefore, the R66 has no active SFAR, and neither will the R88. The R22 and the R44 will not have an active SFAR by the end of the decade. For historical background, the R44 should never have had the SFAR applied to it, and our recently passed VP of Engineering, Pete Riddell, hopefully I'm pronouncing that right, made it clear that he only accepted it because it helped accelerate the R44 approval, and he was very regretful for not fighting against it harder. He pointed out that the R44 main rotor inertia and RPM decay rate is bang on top of the Jet Ranger, so it should not have been applied, but it was more expedient to get the R44 certified. So if you're not in the helicopter world that much, this is like some pretty groundbreaking information. That SFAR 73 is going to be gone in 2029. That is huge. It's just a big deal. And then secondly, that SFAR 73 was initially only going to be applied to the R22, but they pushed for it to be applied to the 44, and it did end up going through, but they had regrets about it, because if you have actually flown in R44, you know that the rotor inertia is like pretty incredible. You can do some like crazy autos. If you enter an auto rotation, it is not like a quick drop like the helicopters, like the turbine helicopters I fly now with these big advanced rotor systems. The helicopters just fall. They don't auto that well. But a big heavy rotor system like the R44, a Bell 206, that heavy rotor system has so much inertia that it's kind of more like just like a steep approach instead of like a falling auto rotation. So that is huge. The R44, they say the R44 should have never had SFAR 73. So pretty incredible information there. So with all of that being said, here is my interview with David Smith, CEO and president of Robinson Helicopter Company. I hope you enjoy. I am extremely excited today. I get to introduce David Smith. This is a crazy opportunity I have. David Smith is the CEO and president of Robinson Helicopter Content. He was just telling me before we started that he actually likes my content, so I don't know what that means, but he watched some of our stuff. He wanted to have a conversation, and I wanted to talk with him too. I've posted a couple videos recently about the R88. An absolutely groundbreaking big deal, but definitely some questions. I know a bunch of you have left questions underneath my videos, comments, some critical, some super positive. So we get to hear from the president himself. David Smith, thank you so much for joining us.
Thanks for the opportunity, Devin. Appreciate it.
Yeah, absolutely. And I just want to start the conversation by saying thank you for doing this. It is a remarkably big deal for Robinson to do this. I can't imagine coming in and having the R22, the R44, and the R66 as a product line, and then trying to do something new, because we know those helicopters. This is a totally new helicopter. So can you just break down how the R88 came about, how the conversations came up, and then talking about getting into a new sector, and then of course we'll talk about the rotor system and all the helicopter specifications.
Yeah. Well, so first, Robinson is a world-class helicopter manufacturer. We want everybody, and probably all your listeners, should come visit sometime. Love giving tours. Part of the reason why I am at Robinson today, when I was with a previous manufacturer, Bell, I did a number of years at Textron and learned a lot while I was there. We studied Robinson. We were trying to make sure we didn't let Robinson climb up market into our, at that time, the Bell 407 and onwards up into the 429. And I got exposed to Robinson in terms of understanding how awesome vertical integration is, how really incredible the product are from using the right materials that work well in the world's toughest environments. I was just watching videos earlier of cattle mustering, which is one of my favorite complex missions where the aircraft, really the pilots fly them a lot by sound. They listen to the rotor and they're managing the most difficult maneuvers and they're trying to motivate these stubborn animals to move around. And I love that mission, but I think it gave me the exposure to Robinson as a masterpiece. Each of these products are thoughtful down to each rivet and each component and all the materials that make it up. And it's a really amazing thing. Hardware defines all the great things we live in the modern world. So I think the fact that Robinson is really at the core a hardware company, and we build the world's best helicopters for that reason. So I love that. The 88, when I came in, I mean, part of the reason why when they recruited me was, hey, let's make sure that we continue growing the product line. My predecessor and my engineering VP's predecessor as well, they wanted to start this product. And actually, Frank wanted to start the R88 2 decades earlier, but he felt like from the 22 and 44 progressing up into a Huey, which is what he grew up with, was too much, too fast. And so he wanted to start with a turbine. So he went with the 66 and wrapped the aircraft around a really good Allison engine that has proven to be an awesome market for us. But he didn't want to stop there. He just ran out of time. Frank did. Kurt, my predecessor, was not an engineer and really wanted to make sure that Robinson was well taken care of into the next 50 years. So he wanted this, but he didn't want to start something and then not finish. So we spent quite a bit of time as soon as I started, and my VP of engineering started a month before I did. And we basically said, let's go do this quick. Let's get start engaging customers. We got all the requirements lined out in the first few months, had really great conversations with thousands of operated aircraft, the executives of those companies, and got really all this that you saw unveiled was really the basis of discussions we had with the world's leading air medical pilots and operators, tourism operators, utility firefighting operators. And this is what they asked for. And so, we'll walk through some of the specific design decisions, but it was first requirements and then really understanding, did we do a good enough job explaining what Robinson's approach is, which is, we have some different things. Our maintenance philosophy is very different than everybody else. We can talk about that. I think our rotor and our material choices, people ask about composite blades, they ask about composite fuselage elements. All those things are actually counter to what most of the competition does, but resoundingly customers ask for it. And same thing with integrated versus federated avionics. That's something we've heard a lot about during our discussions. I was surprised at how much I heard about that because I lived most of my career being told a story, a narrative that was not true. When you talk to operators, they tell you truth. And we got a lot of different things than what I heard, from my forefathers, a decade and a half earlier, So that's just some of the examples, but yeah.
No, that's absolutely incredible to hear. So you're saying that the R88 didn't just come about when you walked in the doors. The thoughts were already in place. They were thinking about growing the Robinson line, so they wanted to expand. And the next thing we're going to talk about, and this is obviously the biggest thing, I want to compliment the body of the helicopter, the fuselage. I think it's fantastic. The main thing that, since I have you here, I want to talk about the rotor system or talk about the rotor system. And you said you went out and you talked to operators. You talked to tour operators, just people flying their R44s and 66s around. You talked to air medical operators, utility operators. You talk to these people and you say this is what they want. Can you talk me through how you decided to stick with the two-bladed rotor system? What were the thoughts? What were the conversations like in the room? Because I'm sure you've got people that are very passionate. Were those meetings heated? Did people really get passionate about it? Tell me everything that you can about this two-bladed rotor system, and then we'll talk about it after.
Well, first thing is every important decision you make in engineering is a heated discussion, and it's one with passion on all sides. So, and I've worked with lots of multi-bladed systems. My engineering VP, he flew a lot of Airbus products over the years and Bell products over the years. So we're very familiar with, he flew MD as well. I mean, like lots of product. We know the full landscape of options, and we know the pros and cons of those types of systems. And there are a lot of pros to high performance multi-bladed systems, but the cons these last probably 10 years have been particularly painful for operators. And so we heard resoundingly in the requirements discussion that the difficulty of both keeping blades in airworthy status and repairing and keeping them in the supply chain so that the turnaround time didn't impact their business. There's a lot of aircraft sitting on the ground all across the country and really around the world waiting on blades. The story is like simple, easy to maintain, easy to repair is the right answer here. And for us, we don't tend to have a lot of repairs of blades. People basically just send them back. We send them a new one. And we're making blades to the tunes of thousands per year. And the scale of that is attractive right now. In a world where there's not healthy supply chains in a lot of industries, blades are a good example of that. Engines are another good example of that, and why we went with a single engine versus a twin. In a world where I have not seen yet an R66 engine failure in the whole fleet history, it's hard for me to say that a turbine engine, you need two of them. And again, you're pumping fuel into both. You have failures that happen only because you have two of them. So there's issues with fuel interconnects that are complex. And again, lots of parts, lots of airworthiness. So these are decisions where if we can develop the aircraft in a way like our previous generation, so the 66 is our most recent, we derate the engine, we give it a simpler, easier life. They just don't fail. If they're maintained well and they are put in service in the right context, they live forever, nearly. And so similarly on the main rotor system, we wanted hallmarks of the product: field repairable, easy to pre-flight, easy to hangar. I was in Brazil, and we have a hangar. One of our larger dealers in the world is in Brazil. They have 10 sites. One big site has over 200 Robinsons in one hangar. And they can do them side to side to side to side to side. And they literally run on kind of like a timeshare or like a hangar it, and then it's available for the weekend trip out to their property or whatever. Or another example is news gathering. They have these aircraft ready to go for the evening and the morning traffic, right? And they're there, and they can only make that work logistically because the Robinsons can stack in a hangar just like cordwood, And obviously there are drawbacks. And so some examples, and I'll focus on some of the ones you've brought up, which are great, absolutely true points. There is a concern about low G in any underslung two-bladed rotor. So some things that the modern world has, the Hueys didn't, the Jet Rangers didn't, the 66 and 22 and 44 didn't until recently, are the new advanced autopilots out there. So we're super excited, and I'll give you kind of a scoop on this. We are within days of getting approval for the Garmin autopilot, the GFC 600H, on the R66. That is a precursor for the 88 4-axis that we unveiled as part of the 88 launch. And a really key aspect of that is Sean, my VP of engineering, led that at Garmin when he was there. And he spent all this time getting into low G so that he could train the system how to mitigate low G. So the system inherently, if you're not on the controls, the system will guide you out of low G. It'll reload your rotor. It'll drive you away from low G events. And again, you're not supposed to get in them. And we have plenty of customers who go 30,000 flight hours, never encountering low G in their entire career. So it is not something that just happens to you. It's not like a lightning bolt. There are conditions that are commensurate to that. There are certain regions where you have, seasonal turbulence, big updrafts and downdrafts, things that can cause it in a unique way. But the reality is, in the broad part of our fleet, we don't see mass bumping or low G anymore because the SFARs were actually really effective at the beginning of pilot's career and not really exposing that. So I'll ask you, have you encountered low G inadvertently in your flying career?
Well, thank you for the question. No, I have not inadvertently or advertently.
That's
low
right.
G mass, and people say, I have to say, the helicopter industry, people talk and pilots say all sorts of things. But one of the things that I learned when I was a student pilot, and one of the things that I taught as an instructor, which is 100% true, is low G mass bumping is avoidable entirely. It's all about education and how you fly the helicopter. Things can happen, but low G mass bumping is avoidable, and you can fly a Robinson product 100% safely. You can fly any two-bladed rotor system or three-bladed or four-bladed rotor system safely. Yes. You can also fly a four-bladed large turbine helicopter really stupidly and get yourself injured.
Actually, I commented on a couple of the comments in your comments of people who commented. I shared there's some terrible examples that people should know about. There was two professional air medical operators. One was a Bell Training Academy pilot, and one was a professional air medical pilot that had a fatal accident a couple years back, and it was the same fundamental phenomenon that leads to a mass bumping tail strike, which is overflapping of the rotor. And that is a primarily a pilot input related problem. And I tell people it's hard to describe because it's not just the distance you travel. It's actually a rate problem. It's how fast you go from fore-aft pitch reversal. And so that one was really interesting because we had all the flight data that showed the flight data points of the control inputs. And you could see them quickly cross the zero axis and basically cut their own tail off. And I think what's important is Robinson product for many years didn't have the benefit of that. But things that in recent years, the last 3 years, we've had cockpit camera footage that has helped to reinforce everything we're saying about low G mass bumping and the ability for us to mitigate it, both with better training and advanced autopilot features and advanced flight control features that help to give pilots one more layer beyond what they ever had in their previous generation. And I'll go one more layer, which is we spent a tremendous amount of company resources, certification time, flight testing data, down to literally noise testing for all kinds of, for our new horizontal stabilizer configuration. That is now fleet-wide, and we're getting lots and lots of customers to upgrade in the field. We are really confident that was a piece of the story here, where when you go back and look, Jet Rangers had horizontal stabilizers that were symmetric. They didn't have the roll that occurred post low G, right? Low G occurs, you get a roll phenomenon. Pilots instinctively, particularly fixed-wing pilots, they instinctively correct. That's what the Army saw. And of course, the Army had a problem with a high tail, very different problem, but it was a high tail that was driving that roll phenomenon. So in our environment, in our testing, we got some incredible side-by-side footage of flight test pilots that flew it every day with the old design, never having a problem, of course, but they could show the roll phenomenon and how it quickly can cause an instinctive reaction, and then show it with the new tail, and it's gone. It's the roll's gone. So these things all matter, and they play a role in what I think is a perception challenge first, which is that two-blade rotors are the problem. That's not the problem really at its core. The thing that we think is worthy of considered investment and considered R&D for the flight controls is the low G and the initial responses of the crew. Faster than a pilot can respond, that system is on it and trying to protect the crew. And I think that's a huge step in the right direction. So the 88 has that native, and going forward, all the 66s, basically from new build on, are going to have the new 2-axis autopilot standard for the same reason. And we're working the cert plans to get it down to the 44 and on and on and on. But reality is, this is the next generation of 2G rotors, not your grandfather's Huey,
Yeah, so thank you for explaining that. And I wanna dial in here on something. You said perception. I think, in my opinion, my humble opinion, I think that's going to be the biggest problem, because even pilots have a perception problem with Robinson helicopters. Some of it is perception, some of it is... I know people that have died in Robinson helicopters. Is that due to the rotor system, or is that due to it's the most widely available aircraft that helicopter pilots can fly? It's both of those things. But you talked about perception. One thing I want to dial in real quick, because you're mentioning it, and I think it's absolutely phenomenal, the autopilot system that will help to correct for a low G situation. Let me ask you this. So the R88 is going to come standard with a 4-axis autopilot. Is that correct?
Correct.
Okay. If you are just flying along in your hand flying, will this system help a low G condition, or is it only when the autopilot is engaged?
No. Two different scenarios. So natively, and literally you can turn it off by power resetting. That is obviously breakers and stuff, but the system fundamentally is on, passive, and in the event you're hand flying, it will reduce roll authority when you're in a low G condition, and it will provide cueing so that it's telling you to load the rotor. You'll feel force on the stick to pull back on the rotor to reload the rotor. That's not native to the system. That's even on the 66 2-axis. All you need is the pitch and roll to do that. And so that's the first step. But then, of course, many pilots, particularly with a 4-axis system, they'll be flying on the system without any hands on stick. It will do all of that for you without requiring your action. And so the benefits of these newer high authority servos that are built into the GFC 600H give much more force authority than what our current generation of autopilots offer. That if you've flown the HeliSAS system, it is a different type of design. It's intentionally able to be flown through, and then it kind of resumes, but it's low force. It's not intended to overpower or to cue the pilot in the way that the GFC 600 was built. So it's a really neat step up in every respect. That's partially why we made it part of the standard ship, is that it is a big improvement in kind of total safety for the fleet.
I can't agree enough. I think this information is absolutely critical, and to operators and pilots out there, having this redundant system, the training is the most important thing. Training is absolutely the most important thing, but additional systems increase safety margin, and I think that's huge. So let's talk about these conversations you had with operators. You are targeting a completely new market for Robinson now. You've obviously worked with operators in your past life, helicopter air ambulance. In your promotional content, you talked about helicopter air ambulance, utility, firefighting. Let's talk about this. So the R88 as a helicopter air ambulance platform. The two-bladed rotor system, I think that's a perception problem, but I think potentially there's a lot of hope there. How do you see the R88 working as a helicopter air ambulance? Couple of the other problems I see with it. No, go ahead.
Let's set the stage a little bit. One of the big things that we heard in particularly air tourism and air medical, those two areas indicated that we're coming up on a point at which the cost to operate their fleet and the amount they can bill their end customers are going to cross over to the point where they can't really run viable businesses in all the markets they serve. So that's terrible, of course, because, unfortunately, if you don't have an air medical in your neighborhood, everyone goes by ground, and that is lives lost in the end. And so Air medical is one of those missions we should fight to keep healthy. And so cost was the big driver. And so when we talked with them, there were several in the group who built their careers off the Long Ranger in particular, but the Jet Ranger family, and really understood that you can, of course, do helicopter air medical work with two-bladed systems. And when you consider zoom out one more layer, we're a global business. 2/3 of our ships, really 3/4 most years, go overseas, not to Europe where there's twin engines and multi-bladed and all kinds of things, but in Southeast Asia and Australia and Brazil and India, places that the world has not gotten to this sort of boutique, sort of, very, very specialty thing of I can afford as many blades as you want to throw on my aircraft and as many engines as you want me to buy, I'll buy it. That's not how the rest of the world really works. And so for us, we see a market that is trying to make a solution that can be available to the world and be field repairable and not have this very challenging tail. I mean, one of the things that my engineering lead complained most about when he managed one of the competing products was he had to have a mechanic on staff all the time to do annuals and weeklies and dailies and monthlies and all these various things that are crazy. And like Robinson from the beginning, before there was a real problem, Frank saw that the ability to depend on having mechanic talent and engineering talent around the world on your roster is difficult. And it's a constraint you don't want to have. You want to be able to deploy to the outback and not have to bring a mechanic with you. The only way you can do that is you say you give them long intervals, you give them things that are just really straightforward to easily visually see airworthiness and not have to go through this sort of 10x mic and complex service and support. So I think there's a piece of this that is trying to answer the global question, not just what we see in the U.S., not just what we see in Europe. But the other side, the thing that they brought up a lot was if we can handle the vibration, the two-bladed rotor systems were always more economical. They were always more dispatchable. They were easier to get parts. Those were all truths about the Jet Ranger generation. And as the products changed, because truly the story is the company stopped building two-bladed systems, not the customers stopped buying them. My very first, as a young engineer, very, very first exposure to customers. So this takes you way back, 20 years ago. So now I got to meet a bunch of guys from South Africa that were flying 222s, 230s, and 212s. They were there for a maintenance class at the Bell Maintenance Academy, and they spent like a month and a half there learning the old products and how to maintain them. And they kept saying, why'd you guys stop building these things? They're the best. All the other stuff, it breaks, it shakes, it fails in slow ways, it fails in mysterious ways. And they said, why did you make the pivot? And I asked my elder engineers at the time. They said, well, it was a political thing internally. We decided these things because we had gotten into advanced materials. We had gotten into military programs for multi-bladed, high-performance rotors, all interesting things. But then we said, well, we're going to go sell those commercially. And they're like, well, do the people want to buy that? Well, we won't give them a choice. That's not a great recipe. And so when you start unwrapping some of this, I think there are great lies in the world. And I don't mean this is one of them, but I'm saying like in the big picture, how many blades do you need to fly a helicopter? How many engines do you need to fly a helicopter? How many engine failures have you had on a turbine aircraft? And you think about those things and it's like, well, damn, I'm lugging that thing around all the time. In a world where we care about emissions, we care about sustainability, we care about supply chain, how many engines can be produced by the industry in a year. All those things to me are reasons to say, maybe we go and drive and push for a lean, simple product that can be used for the world. India, for example, is right now denied the vertical dimension because there's not enough pilots and there's not enough aircraft. And so our goal is to build both for them, you know?
That's a fantastic point, and no one wants to listen to me, but I'll just quickly elaborate and build on this point.
Yep.
Where I work in the same hangar, we have an R66, and they train pilots from foreign countries, and they use R66s to do medevac missions. These are people that are sick and injured that use an R66. So I mean, you can imagine if you're like really injured, climbing into an R66 works, but it's not the most ideal platform. To have an economical option that on the back lowers down like a truck bed, and you can slide a litter in there, a stretcher in there, but it's economical. You don't need two engines. I do helicopter air ambulance in a single engine. We have more blades, but there's not necessarily, I don't know, a benefit over that. I mean, the low G mass bumping we talked about. One thing I do want to quickly ask you about is the speed and the sound. So with a larger rotor system, you can go faster. Your V&E is typically higher. What is the speed? First question, what is the speed you're looking at for like cruise for the R88? And what's the sound profile? Because we work in our communities, we work in neighborhoods, we're flying into local community hospitals. A big two-bladed rotor system, as much as us pilots and engineers and aviation enthusiasts love that whop, 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 some people don't. So what do you guys think about sound profile and being good neighbors and speeds?
Okay, so I want to hit a couple things. I did miss a point that I think I want to emphasize that one of the things about the aircraft design is disc loading and how much sort of weight you're hanging by the rotor. That affects things like downwash, which is part of flying neighborly. In general, Robinson has been, over its entire career, the most efficient lifter in the world because we build long, slender rotors. We make sure that they're loaded light generally. That's why people sometimes have challenges with gusts on a R66. It's ultra lightweight, and why we recommend generally people try to load those aircraft up. Now, the 88 is positioned entirely differently. As a system, we are loading it more. As an aircraft, it will be more similar to something like the product you fly today, where they are more heavily loaded. It's still going to be more efficient. It's still going to be measurably better than the efficiency of our competitors, but it is one of those things where, in general, it's going to feel somewhat heavier, somewhat more robust than what you're used to feeling, and so it won't be thrown around by the wind. Part of that also plays into noise and speed. So what drives speed is generally as you're going at full speed on the aircraft, the advancing speed of the rotor, right? So that's as you get close to Mach, you start to have real serious compressibility, you get loud noises, you get loads go up really fast. All those things drive your reason why you set a speed range. But plenty of fast, 155 knot and above, two-bladed aircraft. The challenge is you got to pick that point carefully, and it will affect noise. So truly where we're aiming for is every customer we talk to says the difference between 125 and 145 is pretty small. Even though you might tell yourself it is bigger, you're talking 30 seconds, 60 seconds, 90 seconds of decreased travel time. So what we were told is aim for above 135 and you're good. And that's generally true. I mean, we see that even today in our 66. You can go that fast. A lot of people choose to go slower for all kinds of reasons. Efficiency, fuel burn, noise, vibe, all those things. So I think when we get into flight tests, we'll know much more precisely because until you're flying, you're guessing at drag. You've got elegant tools to guess better and better every generation. But the reality is until you fly, you just don't know. A lot of things change a lot just based on center of gravity and how the aircraft knows kind of is positioned or not. And so I think we'll start to see this become a lot of our flight testing in the early flight tests to validate drag profiles and performance. Back to noise. So one of the things that the industry's gotten really smart about this, and I think we certainly have plans for it. We're not going to overcommit to what we'll produce, but you can have a couple of different set points for noise so that when you're flying in noise-sensitive areas, you're flying at 1 RPM, and that drops that tips way, way down very, very fast. And so that's something that we are absolutely planning to experiment on the product. And if we can deliver it with all the performance margins and we can make sure that it's certifiable in all the ways that it needs to, then I think it will be something you see in the 88 before it gets to market. But there are drawbacks. I mean, dynamics is the enemy of an aircraft. And so sometimes at lower RPM, the whole system is rung at the wrong frequency and you see fatigue loads rack up fast. And so the aircraft tend to have a sweet spot of where they really want to operate. And so if we can offer that to customers, that is part of our plan. It's a matter of where and how much it reduces the noise. But yes, I do think as an aircraft of all, and I'm biased, of course, but honest broker here, no one told us they cared more about noise than they did about payload or economics. That everyone told us we need something because the business is going to go away is what they tell us. And so it's important for something that does the mission And for firefighting, for example, not a single customer said, "Oh, I need it to also be quiet." They want to carry the water and get up and go every day, and that's us. So that's the kind of stuff that I think is our mission, and we may not win certain profiles, but I'll tell you, it was clever for us. I'll give credit to my team on this. Some of these noise profile requirements are based on number of seats, and we have the most seats in the class. So Grand Canyon is set by seats, not by gross weight of the aircraft. So we have 10 seats on that aircraft. So it's a better threshold requirement than our competition, who has 6, 7, or 8. So we're in a decent shape, I'd say, starting off.
So in your promotional material, you talked a lot about firefighting, helicopter, air ambulance, utility. You just mentioned tours there. Obviously, I think the area where this really could shine, in addition to all the other areas, but is tours. Grand Canyon, New York City, all the Las Vegas Strip, all these areas. Did you guys, I'm sure you did, but can you talk just quickly, briefly about the viewing experience for passengers in the back? Because from the pictures, I would argue that maybe a different helicopter has better viewage, like a 407 side windows, EC-130, different viewing experience. Yeah. So go ahead.
It's deceptive. So I'll say there is the middle back seats. So there's 10 seats in the aircraft. 8 of them are awesome, are better than the other guys, because the window depth and the window distance to you basically look out and you're like in the sky without the doors off. It's like almost like doors off flying, but with doors on. But unfortunately, those middle back seats, those 2 seats in the center back, frankly, are not going to be as lucrative. But I talked with a number of air tourism operators. Their answer is today, people sit in the back of an A-Star and they are in the back middle, and their view is not that great either. And it's still flying in a helicopter. There are still views that are fantastic. It's maybe like riding the back middle seat of a Ferrari. There isn't a whole lot of space in those cars. But I mean, like these are the things where you're comparing the access to this awesome commodity of flying in a helicopter over the Grand Canyon, the Niagara Falls, versus not having it at all. And I think we open up an entire economy. So one of the key points that I think is worth highlighting is people are often misunderstanding the pricing of our industry. And so we are super transparent about our pricing. Our stuff's on the website. People can see everything about how much every part costs and every aircraft costs, every configuration option. The 88 is priced more than $1.5 million less than competition. That's where it is. So 3.3 doesn't sound like a low number, but if you were to buy a new product from any of the competition, it starts in the high 4s. That's people will tell you can start with a base ship, but the reality is they all have customizing, they all have configuring, they all have weird delivery fees and all kinds of things that get you back up to nearly $5 million per aircraft. And so the intent with positioning this aircraft is we've got a huge factory. We have the most vertically integrated supply chain. So I buy the least things from the least people. And I have in our command of our aftermarket, we have 100% of the component repair and overhaul of the entire fleet. So our economics are unbeatable. And because they're unbeatable, we are using that and giving our customers this opportunity to hopefully grow new businesses, but at the very least preserve what they've built. And so I think, to me, the opportunity is pretty exciting, that it is something that literally the message we got most commonly from our competition at Verticon was, well, I don't think they can hit those numbers. And they meant the dollar numbers. And they came and asked, and they were like, oh, now I understand your business isn't like our business. And that's true. We are nothing like the other guy's business. And I think that's... Yeah.
Let me just ask this real quick. So 3.3, if you're targeting a helicopter air ambulance, that med interior, what is that going to cost? Are you guys going to do that in-house? Are you going to push that off to another supplier? What is that going to cost?
Great question.
Additional on top of the base price?
It will cost more. Yeah, it will cost more. Our history for missionizing is to do as much as we can to make it an easy configuration for the end customer. Law enforcement's a good example of that. We really built an entire law enforcement aircraft, and then typically they will add some features to it after they take delivery, but not a lot. Our competition generally gives that to a third party. They do the whole thing with another layer, another whole cost and expense and schedule. So what we're trying to do right now, and we have several years of evaluations here, but we have several partners in development that we hope to sort of publicly announce and share the details. But these are the professionals of the air medical industry, folks that see the promise of a landscape like this. That's a low starting price. And then customers can layer on top of that the latest generation of air medical equipment. And so I don't know what the price will be. I wish I could tell you, and I would love to put on the website. But reality is it's going to take still some time to evolve with them what the best setup is in terms of things like nurse positioning of the seat. Does it need to gimbal, or does it need to swivel, or does it need to stay put? We had all those discussions with them. They came and visited and did measurements of the mock-up and all that multiple times. I mean, they've been with us for 18 months, so it's not like this is a new discussion for them. But the discussions we've had have been, they love the landscape, and they love the fact that it's going to have ample power. Electrical system power is always a limiter. And so you don't have to do mods to add that stuff. All you need to do is plug in. And I think that's going to give it the easiest, fastest integration. And again, back to how we run our business differently. A lot of times if you go look at our competition, every one of them has a site that does that work, and they do a third party. So they're internally competing between a partner and an internal resource. And that's all confusing. And like in the end, there's all these sort of false incentives and sort of weird setups that comes from that. We are not an integrator. I want a partner who is an expert in this, and that's going to give us this edge where we'll be the best partner for aeromedical integrators anywhere in the world. And there's some in Europe and there's some in the US that cover kind of different approaches to it. And I think we're going to be great partners for both of them.
And I won't waste all your time, David, because I know you're a very busy man, but I just want to highlight that point. That is a huge point. And for us in the helicopter air ambulance industry and pilots that are coming up through the industry that want to use their skills to help people, whether it's helicopter air ambulance, firefighting, utility, if we want to help people, we want helicopters out there that are helping to save lives, make improvements in the community, and having an affordable, safe option is huge. People like to get into the nitty-gritty of two engines, multiple blades, but legitimately we all love helicopters, and we want helicopters out there flying, making a difference in the community. So having an economic helicopter, you guys have the largest parts distribution network. I mean, your suppliers, you guys have dealers everywhere. There is something to be said about what Robinson has already done. There's a reason why you guys build the most helicopters. It's important, and you guys do really good work. I want to ask one final question before you run. You are now competing with like the very large helicopters, so I'm bought in, but what is your selling pitch to others on why they should choose the R88 over a 407, a 130, an A-Star, now that you're targeting those guys?
Yeah, I mean, truly, I would add the 135, the 145. I mean, like,
yes,
the 09,
yes, the 130, yeah.
I mean, and I'd argue that in a world where you need to accomplish a mission that is lift something a long distance safely in instrument rules, potentially, this aircraft is going to offer you all of those things at an unbeatable price. We do the most manufacturing of all of our peers, and I think that means something today. And it means that you can depend on us to get parts. You can depend on us to get service and repair. You can always depend on us to be transparent on pricing. So all those things means that if I'm starting a business or if I'm running a business and I find it hard to close the books every month, I think this is the tool that you've been looking for. And it will take some time to get to market, and it won't be everybody gets it right away because production rates will be the best, but it does take time to build a lot of good things. So I think if people want to learn more, they should come visit us. And I think it is so simple. We've been hosting a bunch of folks from the U.S. Army over the last several months. When they come visit our facility and they come back to back from another OEM and they come to us, whether it's fixed wing, rotary wing, or whatever, we are unique. And I can't stress enough. It's not stuff that I did. I married well, I guess. That's the way I look at it.
Yes.
And in this, like, the history of the company was built off fundamentals that we've lost in the industry of making things and actually putting in the hard work to turn metal into aircraft. That's done elsewhere by all the others. We do it here in Torrance. And so it's part of the reason why we bought the drone company and brought that into our family too. We see a future world where these things work together, and it's benefiting from the scale of economy that we bring just because we do so much. And I love that, like, in the long run, it can be useful to more missions. I was probably most impacted early in my career from missions like air medical, where like these things save lives in ways that nothing even comes close. There isn't even a solution for this stuff. And we heard about like the fact that the V-22 was saving lives that would otherwise have been lost in last generation's wars. And that was a tool of vertical lift, just like the air medical is in your space. So I think, we take these missions really seriously. It's our entire life. I mean, it's existential to us to be good at this. And so you'll see that more and more from what we put out and what we share. But the best thing is come visit and people can see it for themselves. And that's the best way to sell our business,
David, I can't thank you enough, and I just want to push it on that point because I am a proud patriotic American, and you are building right here in America. I have the American flag on my sign because I am proud to be an American, and thank you for building these helicopters here. Thank you for hiring and employing. I was doing some research before. Over 1,000 employees that you guys pay, and you feed their families, and you are building helicopters that are saving lives. You're in a very important company. It is funny how we all get haughty-taughty about, and I do it too, about the helicopters we're flying, the engines we're flying, the number of blades, the avionics, but you guys are doing incredibly important work, and the R88 has a lot of potential. I want you guys to succeed. I think you guys have the team behind you. I think you have the leadership behind you, David. I think you are leading from the top. I think you have a great head on your shoulders. I think you know what you're doing. I think the team behind you, I think your employees, everyone sounds passionate about this project. If someone wants to buy this R88, last question, when will it be in their hands? Like, if I just stumble upon money one day and I want to go into the backwoods, upstate New York, and go fishing with my R88,
I'm not going to give you a number. I'll tell you that we've got a lot of orders already. And so what's good about that is obviously it's popular. We're hitting the mark, but it means that the first year is probably already locked up. But I'll tell you, the best way to think about this is by the end of the decade, we are confident there will be 100 plus in service around the world.
Wow.
The primary markets will be FAA and then some of the more, I'll say, closely aligned foreign authorities. Brazil is a really good direct peer and works closely with the FAA. So we expect that to be fairly fast. Australia, perhaps. Europe will take time. It has both directions for them certifying product and validating them here, and then vice versa for us, certifying and validating in Europe. So I think it will take some time to get into Europe and EASA covered regions. So I think by the end of this decade, this will be a product that you're able to fly. I told my son, I think my son will be flying, and he likely will be flying an 88 when he's a pilot. He's the right age to be like generation 88, So I think we're coming up on
That's
it.
pretty cool. That's pretty cool.
That is.
So are you a pilot? Are you a pilot?
No, so I have epilepsy. I would have been a pilot for sure if I could have, but epilepsy early in my life knocked me out of military service, so I didn't go fly the space shuttle, which is what I really wanted to do back then. Little did I know that flying a helicopter is a lot cooler than flying the space shuttle.
So what you're saying to me is that your son may take you up and fly you around in an R88.
That's right. That would certainly be the dream. And if he doesn't do that, I can tell you he's going to be a mechanic. He has these really cool mechanic and engineering tendencies. He takes stuff apart and comes back and he's built something totally new out of it. I got a box here in the office that's over there. That's old film cinematography equipment from our flight testing here. He's going to take the cameras apart and put stuff together with them. But because of that, he might not really love being a pilot. He actually might love being a mechanic. So we'll see. He's 12, so he's at the age. Yeah.
Either way, both are incredibly important. David, let me ask, last question. I'm serious. How old are you?
42 this year. Yeah. So
look at you leading Robinson Helicopter Company.
Timing is everything, man. I had a great set of mentors over the years. Some really great people that helped make me successful, I think. And then the big thing I tell people is this industry is full of thousands of languages, little specialty languages for aeronautical, fire, and all that stuff. Be a linguist, listen and learn. And I think the great thing about our industry is everyone loves to talk about their little journey in their career. And if you listen and you can pull it all together, then it helps you really move quickly in roles like this, where the primary job I do every day is I translate the needs with the resources, and I make sure that things go in the right place. And that's, like the engineering, I love to be more active in making the decisions on the 88. I love doing the product development. I did the 505 and the 525 a lot at Bell, but I would love to do that every day. But my calling in life is to sit in this office and walk out the factory floor and solve weird problems that pop up and make an aircraft. So that's the mystery now. So yeah.
And so someone has to do it, and I appreciate that you're the one doing it. If anyone wants to go check out Robinson Helicopter Company, they will open your doors wide open. I went to the factory training course. They were incredibly kind to me. Anyone go check it out. David, thank you so much for your time. Thank you for your team. Thank you for all your employees. I wish you guys all the luck in the world, and I'm excited to see how this R88 comes about.
Thank you, Devin. Appreciate it. Keep doing the great work. See you.
Appreciate it.